So U.S. export controls were basically designed to starve China's AI ecosystem of advanced compute, right? But instead, they accidentally created this massive open source juggernaut that is now completely dominating global machine learning.
Yeah, it completely backfired.
Exactly. And if you are an ML engineer watching this breakdown on AI paper slop, you already know we spend like most of our time thinking about model architectures, loss functions, optimization, all that. But today, we are diving into a brand new paper showing how geopolitical constraints actually dictate that architecture.
It's a fascinating angle.
It really is. The paper is titled, U.S. Policies Unintentionally Accelerated China's Open AI Ecosystems. And it's this huge joint study from researchers at Chapman University, UChicago, USC, CKGSB, and the Santa Fe Institute.
Right, a really heavy-hitting group of institutions.
Yeah, and I just want to give you the absolute TLDR right up front.
Yeah.
The U.S. implemented these export controls to throttle access to high-end GPUs, and it just did not work the way they intended.
Not at all.
Rather than just, slowing down Chinese AI development, these policies forced a really hard pivot into open source AI as a pure survival strategy. The authors actually call it resilience infrastructure.
Which is a great term for it.
Yeah. And now these Chinese open weight models like DeepSeek and Qwen, they're heavily adopted in global open source and academic ecosystems. They're actively used by U.S. commercial researchers, even while being systematically, surgically filtered out of U.S. commercial patents.
The contrast there is wild.
It's crazy. So welcome to the discussion. To really grasp how a policy failure led to this massive global shift in AI development, we need to look at the physical choke points that kind of started it all.
Right, because the physical supply chain was really always the intended battlefield here. I mean, to understand the engineering reaction you're seeing today, you have to look at the dual strategy the U.S. deployed over the last few years.
This sort of carrot and stick approach.
Exactly, yeah, the carrot and stick. So the carrot was this massive push to boost domestic AI infrastructure. Think of the T-Chip PS and Science Act back in August 2022 and the American AI Initiative.
Just pouring money into the domestic ecosystem?
Right, heavily subsidizing and strengthening the foundational ecosystem at home. But then you have the stick, which was the Bureau of Industry and Security, or the BIS, rolling out these severely restrictive export controls.
And those came in waves, right?
Yeah, major waves. We saw them in October 2022, then again in October 2023, and most recently in December 2024. And the explicit directive of those policies was to completely sever China's access to advanced AI accelerators.
Which means the absolute cutting-edge hardware.
Yeah, but they weren't just targeting the chips themselves. They were actually targeting the interconnect bandwidth. That's a crucial distinction.
Oh, right. The physical ability for the chips to talk to each other.
Exactly. The specific hardware choke points required to string thousands of GPUs together to train these massive frontier models. If you throttle the interconnect speed, you bottleneck the whole training run.
And the market impact of that was just immediate, visceral. I mean, NVIDIA, for instance, had to take a multi-billion-dollar inventory charge specifically for their H20 chips.
There's massive financial hits.
Right, because the licensing requirements literally shifted underneath them overnight. And when you look at the flagship models coming out of China recently, models that have just completely disrupted the space, like DeepSeek V3 and R1, they had to be trained on clusters of NVIDIA H800s.
Which is a very specific, weird chip.
Yeah, for anyone dealing with hardware procurement, the H800 was essentially this export-compliant bandwidth-hobbled chip. It was designed specifically to skirt those earlier restrictions.
Right, they had the memory, but they couldn't communicate efficiently.
Exactly. So the engineers building these models, they couldn't rely on the absolute bleeding edge of interconnect speed. They had to mathematically work around the physical limitations of what they could, legally acquire.
Which forces a fundamental strategic pivot at the national level. You can't just brute force it anymore. And the authors of the paper highlight this brilliant concept here. They call it openness as resilience.
I love that phrase, openness as resilience.
It's so accurate. Because if you are operating in a deeply constrained hardware environment, the absolute worst thing you can do is rely on centralized, massive, foreign-controlled cloud platforms.
Because they can just turn the tap off.
Exactly. Chinese policymakers recognized that vulnerability almost immediately. So they didn't just quietly funnel money into a few proprietary, closed-door national champions. They didn't try to just build a closed-off OpenAI or Anthropic equivalent.
It wasn't a walled garden approach.
Yeah. No, not at all. If you look at the language in their internal policy documents, specifically things like the 14th Five-Year Plan and the 2025 AI Plus opinions, there is this aggressive, explicit mandate to build an open source ecosystem.
Which seems counterintuitive if you're trying to compete,
Yes.
right? You'd think they would want to hoard the tech.
You would think so, but if you build decentralized models that can be run locally on, well, whatever scattered hardware you happen to have, you instantly reduce your reliance on centralized infrastructure that could be cut off tomorrow.
Right. It's kind of like, say a city has its main water pipeline shut off by a rival.
Okay. Yeah.
Instead of burning their limited resources trying to secretly build this massive proprietary new pipeline that might also get shut down, they just design an incredibly efficient rainwater collection system, one that can be installed on literally any house.
That's a really good way to think about it.
Right. And then they open source the blueprints for that collection system. And fast forward a year, and half the world is using their water system simply because it's the most efficient way to capture water.
That analogy maps perfectly to the software reality we're seeing. Under conditions of extreme geopolitical uncertainty, an architecture that a developer can independently modify, compress and deploy locally, that becomes infinitely more valuable than an API key.
Because an API key is just access to a massive model living on a server you don't control.
Exactly. If a research lab doesn't know whether it will have access to next-generation frontier hardware, its best defense is cultivating an ecosystem of models that are ruthlessly optimized, models that run on the legacy hardware they already possess.
Right. But I mean, declaring openness as resilience in a 5-year plan is just paper strategy, right? Policy mandates don't magically write optimized CUDA kernels.
No, they definitely do not.
So the crucial part of this paper, for me at least, is how it transitions from that high-level government strategy down to ground-level engineering data. The authors wanted to see if developers actually changed their behavior.
Right, they had to measure the actual reaction.
Yeah, so they conducted this massive event study on GitHub.
And the behavioral shift in the data there is just unmistakable. The researchers tracked the forking of large language model repositories, which is, well, it's essentially the core metric of open source engagement.
Forking is like voting with your feet in the developer world.
Totally. And immediately following the U.S. policy shocks, most notably that initial October 2022 BIS export control announcement, the forking of LLM repositories by Chinese developers just spiked dramatically.
Because when you fork a repository, you are intentionally coasting it into your own isolated sandbox.
Right. You are taking ownership of the code so you can modify it, optimize it, and basically guarantee your access to it regardless of what happens upstream. And the researchers quantified this surge.
What were the actual numbers on that?
They found that the China-associated rise in forking was 0.131 forks per repository week, larger than the response from developers in the United States.
Wait. I have to jump in and play devil's advocate here for a second, because if you're an engineer looking at this timeline, something really obvious stands out.
You're thinking about the ChatGPT launch.
Yes. Late 2022 into 2023 is precisely when the global generative AI boom just detonated. I mean, everyone, everywhere was suddenly forking LLM repos because it was the hottest technology on the planet.
Yeah, the whole world pivoted at once.
Right. So how do the authors know this pivot to open source in China is actually a calculated reaction to export controls and not just Chinese developers writing the exact same hype cycle as developers in San Francisco or London?
That is exactly the most critical vulnerability in the timeline. Right. But the researchers anticipated that exact critique. They didn't just measure raw volume.
Okay.
They utilized a difference in differences event study methodology.
Okay, the classic econometrics move.
Exactly. This approach specifically controls for those baseline global trends, the hype cycle you just mentioned. Because if the surge in forking was purely driven by the launch of ChatGPT, you would expect the U.S. and Chinese fork rates to rise in tandem, right?
They would follow the same rough trajectory.
Exactly. But they didn't. The data reveals a very sharp structural divergence. At the exact moments the BIS export control announcements dropped, the Chinese fork rate detached from the U.S. baseline.
Oh, wow.
Yeah, it accelerated at a significantly higher trajectory right at the dates of those policy shocks.
Right.
It wasn't just general enthusiasm for AI. It was a targeted, accelerated engagement with open, locally deployable infrastructure.
That directly correlates with the geopolitical shocks. So
Yes.
the difference in differences proves it's not just the overall trend, it's the delta at the precise moment the hardware gets restricted. And when you look at the research-focused side of things, this is where the engineering reality gets super fascinating.
The hardware constraint changed the math.
Literally.
Yeah.
The lack of access to frontier compute didn't just change where developers hosted their code on GitHub, it changed the mathematical direction of Chinese machine learning research.
It had to.
Yeah, the paper details this massive anomalous spike in Archimic's preprints originating from China that focus exclusively on compute-restricted environments.
Right, because when you hit a hard wall on physical hardware scaling, you have no choice but to scale your algorithmic efficiency. You literally have to shift the burden from the silicon to the math.
Exactly. And let's look at what that actually means in practice. The paper highlights subfields that saw these massive jumps in output relative to the US, specifically things like parameter-efficient fine-tuning or PFT.
Which is absolutely essential if you're constrained.
Right, because if you only have access to restricted hardware with limited VRAM, you can't load a 70 billion parameter model and update all the weights during fine-tuning. It will just crash. You'll run out of memory.
Out of memory errors all day.
Yep, errors everywhere. So Chinese researchers doubled down on techniques like LoRa low-rank adaptation. Instead of updating the whole model, you freeze the pre-trained weights and you inject a tiny low-rank matrix that requires like a fraction of the compute memory to train.
You get 99% of the performance for maybe 2% of the VRAM cost.
Exactly. That wasn't just a stylistic choice, it was an engineering mandate forced by the hardware.
And they also pushed aggressively into low-bit quantization. If your constraint is memory bandwidth, taking a model trained in 16-bit floating point and mathematically compressing those weights down to 8-bit or even 4-bit integers.
Which sounds crazy when you first hear about it.
It does. But doing that allows you to squeeze these massive models onto consumer-grade GPUs. And because of that, we saw a huge emphasis on total model compression, edge AI, and TinyML.
Yeah.
The hardware constraint fundamentally rewired their research incentives. It basically created an entire generation of engineers laser-focused on wringing every last drop of performance out of suboptimal chips.
Which is pretty much the textbook definition of induced innovation.
Yeah.
By making access to frontier compute scarce and politically contingent, the U.S. unintentionally ran this massive real-world optimization experiment on a competing engineering workforce.
And they clearly figured out how to do more with less.
They really did. But this constraint-driven efficiency doesn't just stay in a vacuum, right? Which brings us to the global contagion phase of the paper. We've established that the choke points forged a hyper-optimized ecosystem in China.
Right.
But software efficiency is completely agnostic to borders. When you take an aggressively optimized hardware-forgiving model and release it onto GitHub or Hugging Face, what happens globally?
You see an unprecedented rate of diffusion. I mean, to a developer, efficiency is a universal language. If a model requires fewer resources to achieve state-of-the-art benchmarks on leaderboards, the global community is going to adopt it instantly.
And the sheer volume of what is being released is just staggering. Think about Alibaba dropping over 100 open source models just from its Qwen 2.5 family alone.
There's a massive drop.
Yeah, they blanketed every possible parameter size, catering to every hardware configuration imaginable. And then, of course, the explosive release of DeepSeek R1.
Oh yeah, DeepSeek R1 was a huge moment.
They leveraged a highly efficient mixture of experts, architecture, and heavy distillation techniques to achieve frontier-level reasoning at just an absolute fraction of the traditional training cost. It sent shockwaves through the community.
And the visual representation of this in the paper is striking. The authors actually plotted the diffusion curves for these models. They measured cumulative forks over time after their initial release.
And what did that look like?
Well, the early open-source diffusion curve for a Chinese origin model like DeepSeek R1 maps almost identically to the global adoption curve of Meta's Llama 3.
Wow.
Yeah. These models aren't being quarantined within a domestic Chinese ecosystem. They are sweeping through the global developer base at the exact same velocity as the most heavily funded, well-known open models from Silicon Valley.
That's incredible. But here's the data point that completely upends the narrative for anyone assuming the U.S. commercial tech sector is, like, totally insulated from this.
This is the most surprising finding in the paper, I think.
Totally. The authors analyzed ArcSIF preprints, specifically affiliated with U.S. commercial entities, not just universities, but the actual research arms of American tech companies.
Some big players.
Right. And they found that corporate researchers in the U.S. are adopting and building upon Chinese models like Qwen and DeepSeek at rates broadly comparable to Chinese companies themselves.
It highlights this massive disconnect between political theory and the reality of scientific research. In the decentralized environments of open source development and pre-publication scientific research, national boundaries are just incredibly porous. They're almost non-existent.
Because developers just want things that work.
Exactly. To a machine learning engineer sitting at a desk in a U.S. tech giant trying to solve a specific fine-tuning problem or get a paper ready for NeurIPS, the geopolitical origin of the foundation model is completely irrelevant.
They aren't checking the model's passport.
No, they're checking its benchmarks, they're checking its context window and its VRAM requirements. They just want the absolute best tool for the job.
Yeah, if Qwen 2.5 gives you state-of-the-art results for your specific coding task, and it fits neatly into your available compute cluster, you are going to pull it down and use it. It is pure, ruthless pragmatism.
Absolutely.
But, that pragmatism leads us straight into this massive institutional paradox. Because if you think about it, if U.S. corporate researchers are heavily utilizing these highly efficient Chinese models in their scientific papers.
And actively forking them on GitHub.
Right. If they're doing all that, you would naturally assume those models are deeply embedded in the actual commercial products those U.S. companies are selling. You'd expect to see them all over the commercialization pipeline.
That is the logical assumption, yes.
Yeah.
But when the authors pivoted from tracking decentralized research data to analyzing formalized U.S. patent data, they hit an absolute institutional wall.
A brick wall. The asymmetry they uncovered is wild. The paper lays out the numbers, and if you comb through U.S. patent applications over the same time period, they are just flooded with references to Western Foundation models.
Thousands of them.
Yeah, you see thousands of explicit mentions of Llama, ChatGPT, and Claude. But when you query those exact same patent databases for mentions of Qwen or DeepSeek, it is a ghost town.
Completely empty.
We were talking single digits compared to thousands. So, if the engineers in the research labs are clearly using these models on a daily basis, why are they vanishing the moment the technology tries to become a commercial product?
Because you are seeing the friction between the culture of decentralized innovation and the highly formalized machine of commercialization.
Okay, unpack that a bit.
Well, the Wild West of GitHub, Hugging Face, and Arceive operates entirely on norms of rapid experimentation, efficiency, and knowledge sharing. Everyone uses everything. But the moment an engineering team tries to take that innovation, package it into a core commercial product, and push it through the United States Patent and Trademark Office.
The USPTO.
Right, a completely different set of rules applies there.
It's like building a prototype race car in your garage using unauthorized aftermarket parts you bought internationally because they were cheaper and faster.
Okay, I see where you're going.
And the car works flawlessly on the test track. It sets record times. But the moment you try to pass a formal safety inspection to actually sell that car on a showroom floor, the corporate compliance auditors step in, they look at the supply chain, they panic, and they rip all the aftermarket parts out.
That is exactly what happens at the enterprise level, because a patent is not just a technical schematic. It is a legally binding compliance document.
Right.
When an organization moves to file a patent, it triggers an intense internal review process. Corporate lawyers step in and scrutinize the software bill of materials.
They want to know exactly what's under the hood.
Every single piece of code. They assess procurement considerations, licensing contamination risks, strict compliance obligations, and crucially, geopolitical risk assessment.
Which is a huge factor right now.
Huge. A U.S. tech company's engineering lead might be perfectly happy letting their team spin up DeepSeek in an isolated sandbox to test a hypothesis or, draft a preprint. But when it's time to formally embed that model into the back end of a flagship commercial product,
and put it in a patent application where it faces regulatory and legal scrutiny.
Exactly. The institutional friction is just way too high.
So the compliance risk basically outweighs the algorithmic efficiency.
Every time.
They take all the insights, the architectural tricks, and the optimization strategies they learned from experimenting with the hyper-efficient Chinese model, but when they actually compile the commercial product and file the IP, they just swap the foundation model out for Llama or a proprietary U.S. model just to avoid the legal headaches.
Precisely. As the authors articulate, openness travels almost frictionlessly through decentralized research ecosystems. but it hits severe segmentation and hard boundaries when it enters formal commercialization systems.
The lawyers get involved.
The lawyers get involved.
Yeah.
So the engineers and their ideas are globally integrated, but the corporate institutions remain deeply segregated by legal and political borders.
Which means the actual underlying influence of these Chinese open source models on U.S. commercial activity is likely massively undermeasured by our official metrics.
Oh, absolutely.
Yeah,
patents don't tell the whole story.
We can't see the models named in the official patents, but their optimization techniques and architectural influence are absolutely permeating the foundation of the research labs building those products.
The ideas have already diffused.
Yeah. So if you are an ML engineer tuning in today, let's pull all of this together and look at the whole board. The U.S. government implemented these severe containment policies designed to starve a geopolitical competitor of the advanced physical compute necessary to build frontier AI.
But rather than halting progress.
Exactly. Rather than halting progress, that constraint inadvertently acted as this intense evolutionary pressure cooker. It forced an entire engineering culture to abandon compute-heavy brute force and pivot to extreme algorithmic efficiency and open-source resilience.
A total shift in strategy.
And that pivot created an open-source juggernaut that has now deeply, deeply permeated the global research ecosystem. And while that influence is currently being scrubbed and masked in official commercial patents due to, corporate legal filtering.
The realities of the USPTO.
Yeah, the engineering reality is that these highly optimized models are sitting on developer machines literally everywhere.
It really serves as a profound historical lesson in technology policy. You can leverage export controls to successfully choke the physical supply chain of silicon and copper.
You can stop the GPUs at the border.
Right, you can stop the physical hardware.
Yeah.
But you cannot easily control the flow of mathematics, algorithmic architecture, and open source code across the internet.
It just slips right through.
It does. When you dramatically increase the strategic vulnerability of relying on centralized, compute-heavy systems, you don't stop the ecosystem. You simply accelerate the development of highly efficient, distributed ones.
Which leaves you with a really critical, high-level strategic question to chew on, especially for the technical founders and infrastructure leads navigating this space right now.
It changes how you have to think about the future.
It really does.
Yeah.
Because if geopolitical constraints are going to continuously push international competitors to build incredibly efficient, globally accessible, open-weight models that can run on consumer hardware, does controlling the physical compute frontier even matter in the long run?
That's the billion-dollar question.
Right. Or is the true battleground of the next decade shifting entirely away from the silicon and toward whoever controls the developer community and the open source ecosystem?
It's definitely a paradigm shift.
It is definitely something to think about the next time you are deciding which model to pull from Hugging Face for your next fine-tuning pipeline. Keep a close eye on those arc-if trends, everyone. The shift to algorithmic efficiency is moving faster than the hardware. Catch you on the next breakdown here on AI Paper Slop.